Okay, we're writing things as single logs. Obviously, things are going to get change as we go or be more difficult, but some things are still easy. So I see the addition, and I know, sorry, we're in section 3, Swyk number 1 here. We see the addition, so we know we can multiply the 9 and the 4 and get 36. Now, that's actually an easy one to do, right? Because the exponent on 6, which gets me 36, is 2. They didn't ask me to simplify it now, did they? They said write it as a single log. So even though I know the answer should be 2 in its simplified form, they didn't ask that. So pay attention to the instructions. The next one, however, does use this phrase or word evaluate. That means simplify it as far as you possibly can take it. So let's see here. So yeah, we got the 3 right here using the move it property. We move it because we like to, according to the song. So that's 2 to the third. Now 2 to the third we know is 8. So we have a subtraction. So that means we're going to change it to division. Log base 2 of 64 over 8. So now we're in the process of getting a single logarithm, if you haven't seen that. And that means and 64 over 8 can be changed to 8, right? So now we can write it in its exponential form and see if we can figure this out. We got a base of 2. We got an exponent of x, right? And the argument is 8, which is 2 to the third. Therefore, we know the answer to this whole doggone question is 3, because the exponent has to be a 3. Now, what happens when you get to a situation where you are, literally stuck? How the heck am I supposed to know 14 to the x power equals 15? How am I supposed to know that? I can't rewrite 15 as a power of 14. 14 to the first is 14. 14 to the second is 196. 15 isn't in the list, folks. So that must mean it's going to be some weirdo decimal. This is when the change of base theorem kicks in. All right? Now, remember how you could choose any base you wanted? Log of the argument over log of the old base. I'll say that over and over. Log of the argument goes on top. Log of the old base goes on the bottom. Literally, this is something we're going to type on our calculators. Log 15 over log 14. Is 1.0, oops, sorry. Didn't mean to crunch that all into one space, but, okay, there we go. All right, so if I use this, we've got here is, now, we know that's 14 to the x equals 15. So, how do I verify that this is really, really true? Well, if I took that exponent and put it up there, right, which I don't want to write out that whole thing. If I call this the answer, which it is, if we took 14 to the answer power, what should we get? Well, we better get 15. So on your calculator, you can go 14 caret answer. On all the scientific and graphing calculators, there's an answer feature like that. So if I want to attempt to do 14 caret, I'll just do 1.0. 026. I'll just round it off to that. Notice how it's 14.9943. And let's say I went up there and I gave it another 1. You see how it's getting more accurate? And then a 4, right? It's getting more accurate, and then a 2. Getting more accurate, and then a 9. It's getting more accurate, and an 838. Getting closer and closer and closer to 15. So I know I'm right. Now if we rounded it off to 1.026, no big deal, right? Always look at the instructions that Math Excel asks for rounding. So let's do this and this. 1.026. Now, 3 decimal places. All right, we're good. 1.026. Now, if you're typing it on a calculator, please, I wrote this instruction for you. When you do log 15, don't forget this end parenthesis, because if you do, you're going to get the wrong number. Okay, you can always test it with 14 to the answer, and if you don't get 15 or something pretty doggone close like we showed in the video, then you need to go back and fix it or find out what's wrong. And in a lot of cases, that's what people do on a calculator. Okay, so similar question. Log of the argument, log of the old base. Let's go to the calculator. As you can see, log 22 over log 14 is getting me 1.171. So I went ahead and typed 14 to the 1.71. You can see I'm getting close to 22. And if you wanted to get more accurate, obviously you could throw on more digits here. 1, 2, 6, 7, 6. You know, you could see that you're getting closer and closer to 22. 4, 1, 1, 7. So closer and closer you will get to that number. Unless I mistyped something. Oh, yeah. I got an extra 1 in there. I was going to say, you got to be closer to 22 than that. All right. Back to the math. Like we ever left the math, 1.171, I believe is what we ended up with. Moving on down the road, use the change of base theorem to evaluate the expression. Same thing. Log of the argument. Log of the old base. Type it in a calculator. Let's see if we can do that quickly here. Let's go up here. Dum dum. 18, go down here and make that a 13, and whoa, 1.127, 1.127. We could change this to a 3, 1.127. You can see you're pretty close to 18 there, 1.127. Come on, why is it doing this, man? Get me back to my problem. 1.127. Still the 3 decimal places? Yes, 1.127. That completes that, Swyk. Talk to you later.